Asir, I was looking forward to talking to you. How are you?
Me too. I'm very well.
Very well. The man behind the new OEs? Well,
Part of the group and of the whole team that developed this OIS.
great. You know what? I have contact with many engineers. I'm very lucky that way. But the vast majority of them are usually foreigners, whether they're German, Swiss, American, or Taiwanese. So even though I record content with them and we add subtitles, or sometimes it's even translated with AI, it's just not as close as having someone from here, from our own land, you know? So I was really looking forward to recording with you, to having you explain to us what the process is like for developing a bicycle from scratch, like this new OEs. And that you give me some little details, some juicy info above all, right?
You just want headlines.
Well, headlines. I like being able to convey to the end user, to the consumer, things that are normally out of their reach. Because there's, well, the new geometry, the suspensions, all of that is published on the web, but we lose a lot of that beautiful process that you engineers do of finding solutions to the problems and obstacles you encounter along the way. So tell me, for example, how far back do we have to go to know, more or less? On what date or at what point did you start working on this vehicle that you are presenting today?
Okay. I'll tell you. I worked as a development engineer on the 27 Carbon OIS. That is, I joined the project once the 3D is about 80 or 85% finished. I joined the project and share it with the supplier.
But
Of course, before that, you have to have defined all the 3D, all the kinematics and geometries. That's geometry.
let's say there's another team in charge of that.
That's right. Before development engineering, you have the product manager, in this case, Markel, who prepares the entire specification notebook. The bike has to be like this,
Like this, like this.
like this. It has to have these features. What we were talking about, weight, stiffness, and it defines them.
Some objectives that need to be achieved.
Objectives that can be numerical, like weight, rigidity, and other objectives like what we were talking about, leverage ratio, in this case, regressive kinematics. Well, more related to the bike's own geometry, right? So the product manager defines those features, and then the team, in this case Arnau, who would be the innovation engineer, together with the industrial design team, start shaping that 3D model. And in the validation process and in that process of defining the bike, there are some prototypes we mentioned earlier which come before the carbon ones.
Okay.
They work with aluminum prototypes. For example, on this OIC, we've experimented with many variations and versions of linkages,
Okay.
tweaking the pivot points, which change the kinematics. But we also mentioned the importance of the bridge, right? The bridge that connects the stays. Why is it in the front instead of the back? What difference does that make? It gives us stiffness. Where it applies it, where we lose positive and negative things. All of that is done before opening Claro's molds.
Once you open the molds, it already costs carbon. That has a cost.
You can make modifications. You always have the margin to change things. But of course, it's more expensive and it also takes more time. So you have to try to anticipate. And with the prototypes you make, in this case out of aluminum, you should already have more or less a bike that's good enough to start developing,
Okay.
start validating it.
So, have you been directly in charge of designing the aluminum prototype?
No.
It's another person from the team?
It's the innovation team that comes before the main team.
The previous one. Okay, so is that aluminum prototype designed? Is it manufactured? You receive one, we're talking about, or several one?
An A, L, and M, different sizes, because we have different fits. So more than one prototype.
Okay, and who tests those aluminum bikes?
In this case, since these are the first aluminum ones, we usually have internal people do it.
From Orbea, very close.
Very close to the project, like Markel, for example, who gives pretty good feedback and has that touch for testing the prototypes. Or like me, or like other members of the team.
I mean, Markel, I don't know if we've mentioned his position, but if you want to make it clear, because we haven't really talked about it much, well...
Markel, in this case, has been the product manager for the OIS, yes.
Okay.
And he is the, well, global product manager of mountain bikes at Orbea.
He's kind of like the lighthouse that shows the way we need to go, right? Yes.
In the case of Orbea's mountain bikes, well, he would be Vale.
Of course, you also need people close to you there, obviously, so that the feedback is direct, instant, and so on, but also so that it stays secret in a way, you know? That development, because there's a whole part that's secret.
It's important it stays secret, yeah?
There are confidentiality agreements, things like that, in fact.
To this day, with 3 weeks left until the launch, very few people know about the existence of this bike.
Of course.
Yes, it's important to keep it secret, absolutely.
Alright then. What things can be validated and what things can't be validated with an aluminum prototype? Because, for example, keeping the final weight, obviously weight.
Stiffness. Well, it's very hard to have a value, to have that feeling, the feedback from field tests with an aluminum prototype. But above all, geometry and kinematics, that's 100%, 100%. And what we were talking about, well, the positions of the link, of the rocker.
Bike rocker.
Positions of the bridge, where it's going to give you more stiffness, less. You validate all of that with the prototype. Logically, weights and stiffness are very hard to anticipate with the aluminum prototypes.
How long can this phase of going back and forth with the aluminum prototype last?
Months.
Yes.
Yes, months. I can't tell you exactly how long.
But that's a long period.
It's a period, I think it's key, that later determines how the project will develop. So we're not in a hurry, of course, to test it.
I sense that the more each phase matures, the more you anticipate possible tweaks or evolutions in future phases. When you get into carbon and similar areas, costs can be higher, so
Correct. Or even maybe you finalize the aesthetics and the geometry of the frame, but you say, well, I have 2 linkage options.
meh.
We have doubts. So, okay, we go ahead with the frame, but you can make, like in this case, it's forged aluminum violet. You can do 2 forgings, 2 machinings, and have those 2 options for violet. Then you can test them on the bike. So anticipating those things, yes.
Okay, so let's imagine that the aluminum prototyping phase, okay, has already been tested, it's already been verified. Next phase, where do we go from there?
Okay. The innovation engineer now goes all in with 3D.
You get to work at full speed.
Arnau, in this case,
Arnau, innovation engineer. Sorry, no, yes.
he goes all out with 3D, and the development team, well, in this case, I have to say that since OIC is a very powerful platform, we've put in more resources in our team, and what usually is done by one person for that 80% in this case, we've done it with 2 at the neck. So that double check has been important.
4 IC more than 2, right?
Exactly. So the 3D is about 80% ready to share, and then we come in and start iterating with the frame provider.
Okay.
We share the 3D. These are the features we want. We want to have this stiffness, these weights. This is the goal. There's a quote, and we start working with the provider.
And from there, the first carbon prototypes arrive.
Exactly. Well, you share the 3D, you finalize the 2D, the drawing.
All right.
You open molds and wait for the first prototypes. First, you get looking samples, which are prototypes you can't ride. You can't ride or scratch them. You can't mount them, you can't ride them, and you can't do field tests with them. It's simply to check the aesthetics, the assembly, and a bit of the bike's presence.
The presence of the bike.
And then after that come the famous testing samples. That's when you assemble the frame and go all out.
Honestly, which one excites you more? You, personally, when do you get the looking sample, the one you can't actually use, or the one where you say, this is the one I'm going to assemble?
It's true that it's hard not to assemble and use the looking sample on the street, right? But no, the looking sample is helpful, but it's just a first test that helps you.
Like, is the bike sexy or not sexy, right? Yes.
It's more about aesthetics than structure. The real one, the testing sample, is the one that gives you an idea of how the project is gonna go.
But let's say the testing sample arrives on Friday afternoon and you have to wait until Sunday to assemble it and ride it. Sorry, until Monday. It's a hassle, right? It's best if it arrives Tuesday. Wednesday is for exactly.
I assure you that if it arrives on Tuesday, by Friday, it's ready for the weekend. Very good.
Very good. Well, so what's the process once these carbon samples arrive?
Obviously, you have a carbon aluminum frame. You have to validate it structurally. We all know that there are fatigue tests, impact tests, and stiffness tests in the laboratory. That is, these are tests that are not subjective, they are objective. It either passes or it doesn't. It gives you this value or it doesn't. And you have to pass that with every frame, with every size, and you have to do that test and that validation. But that's only one part of the validation process, which would be the most structural part. The other part, as we were saying, is the field test program, field testing, which is more leaning towards the subjective side. Things come up, obviously, if you run a strong field test program. You'll anticipate things like noises, screws that might come loose, or I don't know, torques you need to define, greases you need to apply. All of that is defined with a strong test program, but also the subjective part, that subjective feedback about whether the bike feels good, the feeling if the bike rides well or not, if it lacks stiffness, if it feels too heavy in the front, all of that feedback we collect and then apply. So, as I was saying, as development engineers, we've always had that field testing, those field tests. But it's true that in recent years, with the projects we've had, we've shaped a much more complete field test program that gives us more information. I was telling you about last year about the Ryan project, which is the Enduro and DH bike. I don't know if you know it.
Yes, yes, yes. The one with the DH competition team, exactly.
So during the development, together with the FMD team, we made a pretty strong field test program, especially with Marty Massey guilds were during the development process. Because what's important to mention here is that previously it was the same, that field test which you gathered from the pros, from the teams. It came at a time when the bike was already completely finished and you didn't have any room, you didn't have that flexibility for modifications. In this case, by anticipating and doing testing with these pros well in the phase.
In such an advanced phase, so early, sorry.
In earlier phases, before closing the case, it gives you the chance to modify, to optimize the case before closing it.
So
Everything we learned in Rayon, we've applied in OIS, even improved it. And I was telling you a bit in this case, OIS, well, Rayon was FMD, and for OIS, we've relied a lot on Orbea Factory,
team,
which is the cross-country team for OIS. So, for example, a few months ago, well, actually, it's been almost more than half a year, we did a training camp with everyone from the Orbea factory team, Pierre, whom you already know, Jen, Rebecca, Simon, and they tested the very first OE's 27 bikes, and we already got that first feedback. And I was also telling you earlier about the blind test we did in ESSI.
I really like that. Tell me about it. Let everyone know, because I mean, a blind test for a professional, that's
A challenge for Simon Andreasen. No, our idea was we already have the frame structurally validated, but we have options for different layups. That is same mold, but a different layup. So you can play with the laminates to get different weight to stiffness ratios. So we had 3 bikes in carbon raw without paint, bike 1, bike 2, and bike 3.
no logo, nothing. They had no idea what they were testing.
No idea. But I had the values for those bikes. I had bike 1, it has this weight and this stiffness. And it was exactly the equivalent of an OMR.
Okay, for those who don't know, it's like the entry-level carbon that the brand offers.
That's right. I'm always talking about small differences, but it would be the heaviest and the least stiff, worst stiffness values compared to the Ormex. That would be bike 1.
Okay.
The bike 2 would be OMX, the one you see here.
Okay.
The Layup, which is the stiffest, I mean the best stiffness values and lighter than the OMR. But we did a third iteration because we wanted to try and test with Simon, because we believe that okay, for the end user for sure, this is the layup that we consider to be the best, but maybe not for a professional. A professional might not agree. So we did a third iteration where it was the lightest one that we could make.
And we sacrifice some stiffness.
Of course, when you're already at the limit of weight and stiffness values, if you gain a bit in weight, well, if you reduce the weight a bit, you sacrifice some stiffness. So the idea was Bike 1 OMR, Bike 2 OMX, and Bike 3, the lightest of all, and OMX version 2.
And Simon had no idea which was which.
He didn't.
Not even that they were different.
No, I didn't. I had no idea. Well, we explained to him, like, you have 3 bikes, and these are the features, but we didn't tell him anything else. And we spent the whole day doing the same descent, climb, descent all day in Legutio. And when he did descents with the OMR, well, he ruled it out, justifying it. And what kind of feedback was he giving? And how did he feel about it compared to the others? Well, not as precise in the riding, right?
And he said
This bike, I think it's the least stiff, so I rule it out. And we kept testing, and after the whole day we told him, okay, Simon, tomorrow you have a World Cup race, you have to choose a bike. Which one do you choose? And he stuck with this bike. I mean, in a way, he kind of proved us right, in quotes, and he chose the Layup that we also considered to be the best.
For the rider, that's how it ended up. He could have changed his mind, right? That's it.
That's it. I mean,
the numbers you showed on the screen were correlated between what you saw on the computer and what a pro felt in the real world, right? That people like Fernando Alonso, unfortunately, it doesn't happen to me. The Aston Martin in Adrian Newey's wind tunnel works really well, and then when they take it to the track, it doesn't perform, right? I mean, but...
Wow, but for that you need to have a level of sensitivity, an incredible level of sensitivity.
But the truth is, not all professionals have that level of sensitivity.
Not even close, not even close.
I mean, for example, I was once told at Trek that Anton Cooper was like that, you know? If you changed half a PSI in the front suspension, the guy could feel it. And then, however, there are others who you give them a stiffer fork, a softer one, a stone or a rock, and they ride the same. So having a guy like that with that kind of profile is super positive for you guys too.
We did a good job making the 3 bikes identical except for the layout. That is, same wheels, same wheel operation, same shock tuning, everything the same.
Same track, same day.
Same track, same day, same conditions. Everything the same, just changing the carbon, and we got that. Wow, that
result. And that leads me to ask you a question. Is it true what people say that sometimes the pros in the World Cup, wherever, use bikes that apparently look the same as the ones the end consumer gets, but then because of how the carbon is woven, how it's installed, whatever, they're actually different underneath?
I can tell you about us, but I don't know about other brands. I can't say. But in the case of Orbea, it's always been like that up until now. And this is the first time we've considered the possibility of the pros having a different layup than what the end user can buy. But as of today, and now with today's launch, it's still the same. That is, the Orbea bikes you'll see in the World Cup are exactly the same. They're exactly the same as what you or I can buy.
But let's say you have a super special pro who tells you, well, I need the rear swing arm to be even stiffer. There's the capability to do it.
There's the capability, and it's been done. There's the capability, and in this case, it was put on the table. That is
Simon Andreasen.
If he had chosen bike number 3, I don't know if the whole team would have, but at least he would have had a bike that was ad hoc with the perfect layout for his riding style.
Yes, this is one of the cool things that sets our world apart from motorcycles or cars.
Or Formula One.
Of course, you can't have Fernando Alonso's Formula One car or Marc Marquez's motorcycle, but you can have Valero's bike exactly as he has it, right? That's really awesome. Well, so you go through these tests, and then, of course, the testing opens up to more people. You, the engineering team, the professionals. I don't know if you also have someone close to the team who starts testing once you're working with carbon.
We do it in parallel.
I mean,
At the same time that the people from factory are testing, we are also testing internally, okay? And I was telling you about how we've reinforced the filter program, because in this case, I was the one responsible for organizing everything. The field testing program for OIC and OMR, OMX, all the bikes duplicated.
sizes.
All the units duplicated. We're talking about at least 16 bikes internally at Orbea, plus the support we've also received from the Saltuki team, Orbea factory team. So everything, the whole series of tests we've done, plus all the filters that have been installed, well, it's quite a lot, really.
And all of this in secret for months. I mean, the strange thing is that nobody catches a photo there or, catches you out in the mountains.
We've gone out often, even with attention on us.
Of course.
At night with lights. Yes, you try to avoid, well, the busiest hours. Yes, yes.
Very good, very good. And how does the process continue then? From there, let's say, until you make the final call that this is finalized, let's start production. How does it go on?
This is close, but we keep testing. I mean, even after mass production, we keep testing. Because, of course, here, well, we've done, I don't know, 10 hours. We've probably done that in 3 or 4 days. You can take things out of it, but when it comes to bearing maintenance or, I don't know, or maybe, yes.
I wanted to ask you specifically if during the testing there's a part where the mechanics have the opportunity to give feedback. I say this because the riders and engineers are great, but the mechanics also need to handle things.
I've set up we have a form and a feedback system, and once you've put 10 hours on the bike,
okay,
we bring it to my Avia, we take it apart and check the condition of the bearings, the headset, how the linkage is, if you have any wear, issues, grease, tightness, we mark all the bolts to see if they've moved.
Yeah, it's the usual thing with the alignment, right? Making sure it's aligned. So
every 10 hours you bring it to my Avia, a complete checkup of the bike, and well, identifying the points that have failed or that are in good condition.
Very well. So what do we still need then to reach this point where the bike is presented?
Well, we've gotten pretty close to the moment we're at, because you've already fully validated the frame. You give the supplier the okay.
Okay.
Then they can produce what we call the pilot run, which is a pre-production before mass production.
Okay.
Which is, for example, your bicycle. That is making a production run with quantities that are already quite significant. Maybe, I don't know, 150 bicycles, which are for marketing, press, ambassadors, all those that are not, well, for the end user or don't go directly to the dealers, but they are enough for us to do this kind of press campaign, for example.
All right.
So then that production is already done in the pilot run. We also see how we establish controls over their production, and it also helps us see if the supplier is applying all the quality standards that we require from them. And then after the pilot run and after we see that everything's okay, then we go ahead and...
You hit the point of no return.
Point of no return, well, not return, but full-scale production.
Sure. That button, do you press it? Does the product manager press it? Does the CEO press it? I don't know how it works structurally.
That development responsibility.
Yes?
Yes.
Wow. Do you sleep well that day, or are you a little nervous?
Things were done right, so you sleep well.
Well, it's months of work, well, years.
Years, so years, totally.
Everything is already super verified and all that.
Yes.
Very well. And from there, they arrive, they get in.
They put on makeup, they get in, and wait for June 4th for the launch, and let's see.
Well, you'll see this after June 4th, but we're coming from the past, folks. Very well. And once everything is launched, is your job done? Or in this model, or do you already start working on the next one? I don't know. How does it work?
For us, once it's already in mass production, I hand over the responsibility to the quality team,
Who
would make sure that the quality standards of the frames are validated, are maintained over the years.
let's say,
But we keep, receiving feedback from Climatiza, receiving feedback from the Orbea factory team, continuing doing tests with Simon, because all the information we managed to get, we'll apply it to the OIS 31 in this case. So,
or if there's an intermediate version of this model, like with the previous one, where some things changed.
that's right.
Very well. I was going to ask when you'll start working on the new model, but I don't want to discuss issue 32 since we've likely covered it in other videos. But anyway, you're already working with prototypes and things, so this hasn't even come out yet and you're already working. We're working. We're not idle when it comes to this.
I assure you.
No vacation, right? But, well, in this case, it's a bit special because if it were a normal cycle, let's say a standard bicycle, well, maybe you focus on other projects, let a year go by, get feedback, all that you mentioned, and then after some time you start working on the next one. But since the 32s are there and they need to be validated and you're not even sure if it has to be the new standard, if the next one really has to be a 32, it's not clear.
No, you have to work on it too.
But you have the obligation to know how that's going, right? How it's developing, it needs to be validated and all that.
Yes. I mean, like I told you in previous stages of this OID, there have been prototyping phases. I was telling you 3 years ago there was a kickoff, and then they started working on prototypes. For 30 and 32, it's basically the same. We're in that prototype stage, checking things, finalizing geometries. But well, that takes time, and in the future, it will become a reality. But for now, I think with a product like this, well, we're sure that we've created, well,
the best 29, it's the time to buy the best 29 in history, because this is the moment when this discipline with this wheel size is as mature as possible. No doubt about it. And as for the 32s, we'll see.
We'll see.
Very well, so today, hey Asio, thank you very much. It's been a pleasure. I really enjoyed the conversation, and well, I hope that it's been a pleasure.
That the audience did too.
Leave us comments if you have any technical, non-technical, or curious questions, whatever it is, we'll try to answer them. See you next time.
All right.
All right, see you later. Bye.